Okay, good morning everyone. My name is Andrea Silvestri, and before we get started I'll be walking through some logistics on today's webinar on LED lamps for CFL fixtures. Today's presentation is based on a report by Pacific Northwest National Laboratory, and we'll be hearing from the researchers shortly. You can find the full report as well as a one-page overview infographic and four-page findings and links to additional resources on our web pages at gsa.gov. And I am hearing a little bit of background noise from one of the speakers, so when not speaking, please mute your phones. Thank you. And today's webinar is one in a series of our webinars. We're hosting them once a month on Thursdays. April's webinar will be on electrochromic windows. EC windows are part of a new class of building envelope technologies that respond dynamically to their to conditions. And GPG, along with the Lawrence Berkeley National Laboratory, has now conducted 4 evaluations of EC windows. The 2 most recent assessments examined EC windows in facilities with glass curtain wall facades, and our April webinar will be presenting findings on those 2 most recent assessments, as well as an assessment in a land port of entry. In May, we'll feature the Honeycomb Solar Thermal Collector. GPG and the National Renewable Energy Laboratory evaluated this technology because there's a requirement that new construction and major renovations meet 30% of hot water demand with solar energy, provided it's cost-effective over the lifetime of the technology. In June, we'll be presenting findings on an early GPG assessment of variable refrigerant flow. VRF is now the dominant HVAC technology in both Europe and Japan, though it has limited uptake here in the U.S. At the time of the GPG evaluation, GSA did not have any full implementations to assess, so researchers concentrated on recommendations on where best to deploy the technology. Since that time, GSA now has completed multiple VRF implementations, and the June webinar will present the results from the Pacific Northwest National Laboratory's report, along with the on-the-ground feedback from the recent GSA implementations of VRF. Today's webinar and all GPG webinars offer 1 continuing education learning credit through the American Institute of Architects. To receive credit, complete the post-webinar survey. You should receive a short 5-question survey at the completion of the webinar. If you don't receive the survey, please reach out to Michael Hobson. And today's broadcast is set to listen only, but you can submit questions here, as you've already been doing, here on the right side of the chat box on the right side of your screen. And you don't need to wait until the end of the presentations to submit questions. In fact, we encourage the submission of questions throughout the presentation. And with that, Michael Hobson, the project manager for this assessment, will introduce today's webinar. Thanks, Michael.
Thank you, Andrea. Hello, everyone, and welcome. Next slide, please. Our agenda today. So in today's webinar, Kevin Powell will begin and give us a brief overview of GSA's Proving Ground program. After this overview, Eric Richmond from the Department of Energy's Pacific Northwest National Laboratory will share details and results from our demonstration on LED lamps for CFL fixtures. Eric's presentation will be followed by feedback from Marty Novini from GSA's Northwest Region 10 and from Frank Campagna from GSA's Southwest Region 7. Both were regional project managers for this study. Finally, we'll end the webinar with an interactive Q&A session. And with that, Kevin, take it away.
Well, thank you very much, Michael. And next slide, please. So first of all, I want to thank everybody for joining us on this webinar. In the next few slides, I want to give a top-level overview of why we have at GSA this Emerging Technologies program. Why do we evaluate these next generation technologies and so on? And in some, just so that we're all clear about why, in really kind of fiscally constrained times, why are we doing this activity that some might think of as kind of discretionary? And the truth is that GSA recognizes, as do most large commercial building owners, that adopting next generation technologies is absolutely critical to being competitive in the marketplace and to having the kinds of facilities that are both efficient and effective for contemporary workers. The challenge is that there's a lot of innovation out there. We need to make sound investment decisions in those that actually can deliver real-world performance. Next slide. The thing to understand is that there's a fair amount of investment that goes on, and certainly the one we're going to talk about is no different than any others. But there's a lot of investment at the R&D level of really coming up with product that can essentially solve real problems. The challenge is that when you have innovation in a very conservative, I guess would be the best way to put it, environment like the world of buildings, where things need to work for the long haul, and in many cases, not necessarily in this case, but in many cases, the investment in these technologies is actually rather high. There's a tendency to just simply do things as you have done them before, and that leads to what many will call the technology valley of death. That is to say, there's an innovative product that has had that R&D investment, is ready to hit the marketplace, but nobody is really certain that it's going to deliver in the real world, and because of that uncertainty, it kind of, as they say, dies on the vine. The important thing to take away from why GSA has this Emerging Technologies program is that by doing this activity of identifying things that actually work in the real world, it really has enabled us to invest in the most effective of those technologies. And to date, we've installed, I guess, 9 across 200 buildings. I think that's a little bit outdated. I think it's more like 250 buildings at this point. And at the time we put this up, $7.4 million in annual savings. That is certainly something to think about. Next slide. Just as a top-level view of how did we select this particular LED technology, well, they applied to a request for information, and we put that out every fall. So every fall we put out this general request for information, tends to have targeted program areas. In this case, this was we were interested in lighting. And then those technologies are scored by third-party subject matter experts. We convene, we select the best of the best from what has been submitted. We then choose locations to pilot those. You'll hear from Region 7 and 10 where we piloted these. We used national labs to provide us credible third-party evaluations of how these do. I will say we typically go for what we would consider the acid test installation, so we're not trying to find the best place to try these things out. We're finding the worst and most challenging places to try these technologies out to make sure that if they work there, they work everywhere. And then those that have broad potential for GSA, we look to actually drive adoption through a variety of approaches, which we, in the umbrella term for that, is pilot to portfolio for GSA. And so with that, I'm going to turn this over to Eric Richmond.
Hi, this is Eric. Good morning or good afternoon, whichever location you're in. I'm with Pacific Northwest National Laboratory. We're the ones that did the evaluation of this technology for GSA, and I want to talk a little bit about what we found, what we looked at, and recommendations going forward. So next slide, please. The idea here was to evaluate this product category, LED downlights for CFL fixtures. And this is something that isn't new, but it hasn't been explored a lot because it's not the majority of lighting in a building, but there are lots of downlights. So this was something that needed to be looked at. And this is just a screenshot of the report. There's a report you can get that gives a lot more detail. Next slide. And as Kevin mentioned, there's a process that GSA goes through to identify products or product types that they want to evaluate. And there's a clear savings opportunity here for these downlights of approaching 6 gigawatt hour per year with an estimated 95,000 CFL-based downlights throughout the system in many buildings. So there's clearly a need for this, and so this is why we went with this evaluation. Next slide. So this is the basic product we looked at, and this particular product, there are other versions of it, but at the time we looked at it, this was one of the, it was rather unique. It came in 2 different versions, a strict downlight and a vertical and a horizontal orientation, because some downlight fixtures have CFLs that are aimed directly down and some have them that are aimed sideways. So this is just kind of a format of what the product looked like. As you can see, it has the pin format so that it's directly pluggable into an existing downlight CFL can light. Next slide. These are the 3 facilities that we did the evaluation at. Again, we wanted to look at different facilities. We didn't want to look at just one. We wanted to get a variety of situations and formats and downlight can types, etc. So we looked at a GSA headquarters in Auburn, here in the state of Washington, Federal Building in Dallas, and a Veterans Admin Center in Philadelphia. Next slide. So this is a couple of shots of the type of downlight structures that we were dealing with. As I mentioned, the product came in a vertical and horizontal format. At Auburn, we saw the typical vertical format of the lamp sticking straight down, and in Dallas and Philadelphia, we saw the other format of the horizontal, where there are 2 lamps in each fixture. This product came in both formats, so we were able to evaluate both products in different situations. Next slide. So this is basically the format. We of course looked at the energy use from the 2 different products. We were able to determine that close enough by looking at the wattage, complete wattage, that is wattage of the lamp driven on a ballast, and we determined what those 2 numbers were from the manufacturer's data, used that for the energy evaluation. Of course, we had utility rates at each site. What we wanted to also make sure is that this product will perform sufficiently or the same as the existing product. That's kind of the goal. Now, there will always be projects where maybe a site needs a little more light underneath these can light installations or less light, and of course that will need to be accommodated on a case-by-case basis. But in this case, we wanted to find a product that was meant to provide the same amount of light. So if you were happy with your light, which is most of the time, you just want to save some energy, this is an easy way to do it. So again, we wanted to evaluate and make sure the product was performing adequately. So we set up a grid, and on the right-hand side, you can see there are little sticky notes on the floor and on the wall. And we wanted to evaluate both floor luminance and wall luminance. In some, or a lot of cases with downlights, they're in hallways a lot of times, or they're near an edge of a facility. And we wanted to make sure that this product would reproduce the same amount of light both on the floor and on the wall. LEDs as a technology tend to be directional. So inside of a can fixture, they would tend to illuminate more down than they would to the side of a typical CFL lamp. So we wanted to make sure that we weren't creating an unwanted cave look. So here are a couple of photographs of the grid we set up. To the right is a really scratchy sketch here of the grid itself, showing it on the wall and the floor, and then a raw accounting of the measurements taken both vertical and horizontal for the existing situation, and in this case the Lunera output. And if we go to the next slide, this is an important one to look at for representing what the comparison is like. So the blue dots and lines are the existing previous CFL, and then the orange dots and lines are of the LED that was put in. And you can see that across the various sites, Auburn Dining and their Dallas had a lobby and a hallway, and Philadelphia had a daycare. For the horizontal light levels, the left-hand chart, you can see there's some variance, and of course that makes sense because these are different space types. You're going to light a dining area different than a lobby and a hallway, etc. The important thing to note is that for the most part, a little bit of an exception in the lobby, the light levels determined for both the CFL and the LED are very close to each other. The LED is slightly higher, which is good. Lamps always degrade over time, and so this starts at a little bit higher. And if you look at the averages, the lines drawn across, for the LED, it's 316 lux, for CFL, 278. This is on the floor surface. And they're very similar. LED is a little bit higher, and this is good, so it performs well. If you look at the vertical light levels, same kind of a situation. They're fairly close to each other. It's a little bit mixed in that sometimes the LED didn't produce quite as much light on the wall. This could easily have something to do with where the grid was positioned, because as you recall from the previous slide, in those pictures, there's this kind of archway structure on the wall, which is a product of having can lights dispersed down the hallway. So depending on what the distribution was like for the LED, it may have been slightly different from the CFL, and so the spot we chose to measure would produce a different result. But again, in general, the values are very close to each other, and they show us that the new LED product is providing sufficient light, or at least comparable to what they had before. So next slide. So when we combined this with the energy and the utility rate, etc., we found there was, of course, the lamps themselves had the capability of a 40 to 50% energy savings, which turned out to be, for a typical utility rate, $6.37 a year over a typical CFL. And this turned out to be a little bit less than 3-year payback, which is generally good. Most sites are going to be happy with that kind of a payback. Next slide. So we want to look at, now that we kind of know how this works, and understanding a little bit more about how this product operates, we want to provide some options or some recommendations on what to do with them. Now this product, which I maybe neglected to mention, the beauty of it is that it operates on an existing CFL ballast. So you can pop out a CFL lamp, pop in this LED replacement, and it will run on that ballast. That's the beauty of it. There's no electrical wiring required. You just have to buy the lamp. Now the caveat is that LED products, while they're great, they need to be chosen such that they will work on the existing ballast. These products are developed so that they will work on a CFL ballast, but that doesn't mean they'll work on necessarily every CFL ballast, because CFL ballasts are slightly different in terms of their electronics. So that's the one big caveat, is I want to make sure that it works on your particular ballast. So if we look at this chart, we've tried to identify where these 3 options are the best to apply. One is to do this replacement that we're talking about, pull out the CFL lamp, put in an LED. Another one is to install a retrofit kit, which would be an LED retrofit kit, which replaces the CFL guts, the CFL lamp and the CFL ballast, and replaces it with an LED lamp and an LED driver. And the third option is to install a brand new fixture. So if we look back on replacing the lamp, if your CFL ballast is verified to work with the LED replacement lamp, according to the manufacturer or by some testing, that's great. You can replace the lamp. The other caveat is that typically this kind of replacement, because you're dealing with the CFL ballast, will not necessarily be able to be controlled. Now, some CFL ballasts will have some controllability, but most of them won't. So if you need controls, this may not be your option. Of course, this is the cheapest option. It has a payback of less than 3 years, the lowest cost. Now, if either of those don't work, in other words, if the lamp is not compatible with the CFL ballast, or not all of them that you have, and if you want some kind of control that the CFL ballast doesn't support, then your next best option might be a retrofit kit. It's going to have a higher payback, but it'll still be less expensive than a new fixture. If you're in a new construction situation, you probably want a new fixture anyway. If you're going to be involved with any integrated advanced controls, which are becoming popular these days, then you may also want to simply go with a new fixture. Again, slightly higher payback, but it'll perform better for you. So this is kind of an easy chart to help you determine where you may or may not be able to use this simpler plug-in option. Next slide, please. So a few other considerations beyond what that chart provided. You need to verify that it'll function on all types of ballasts. You may have a facility that's got multiple can lights in it, and some of them are a certain type of product ballast manufacturer, and others are a different one. You won't want to just pull one out and assume the rest of them are that way. You'll want to find some way to do an accounting and make sure that this product will work on all the ballasts. And again, if it's impractical to verify everything, or you know that there's some that won't work, then you may want to consider the retrofit option. And when if you do consider a retrofit option, you need to make sure to identify how low the lamp is going to sit, because that will affect how much the light is distributed. If the new LED lamp sits up very high in the can, it won't distribute light very much to the side. If it sits really low in the can and almost outside of the can, then you may have potential glare problems as you're walking through that area. So something to be careful of. Next slide, please. And a few other tidbits to keep track of. If you have a space that is used infrequently, or you're looking to have a major remodel in the future, you may not want to do that retrofit right away. This is true for any kind of a retrofit situation. You want to look at how much longer you're going to use that space in its current conditioning, in its current situation. Light output, it's true what this says, that LED lamps, because they're directional, can be in a situation where they only need 70% of what a typical CFL produces. The lamps that we tested were designed with that in mind, and so they were designed to specifically replace a certain wattage CFL lamp. You'll want to verify this with manufacturers when you go to pick a product. And color temperature, it's talked about a lot. You can get CFL lamps and LED lamps in basically any color temperature you want. So if you're happy with what you have now with the CFL, you might want to figure out what color temperature that is, cool white to warm white, and identify the same color temperature. If you want to go with something different, then identify where you want to be. You can find all kinds of color chart ranges that will tell you whether you want something that's warm or something that's cool. Next slide. So in terms of deployment, the bottom line here is that it is a great opportunity to do a very inexpensive replacement to get a lot longer life out of your can lights, but there are caveats. It can be as simple as changing a light bulb, but as we've mentioned, you want to make sure that it will work on that CFL ballast, and that you're going to be able to keep that space for quite a while. And I believe that takes care of what I was going to present today. And I'll turn it over to Marty Novina, who wants to talk about his experience and feedback of having this done in a facility he was responsible for.
Good morning or good afternoon, everyone. This is Marty Novini, Energy Program Manager for Region 10. Can you go to the next slide, please? We actually tested a number of lead lamps at our site. Like Eric mentioned, one of the first and foremost things that you should do is make sure that your ballast is compatible with the lamp that you're going to purchase. That's very important because this technology doesn't work with magnetic ballasts or certain other electronic ballasts. Again, like Eric mentioned, the height of the lamp is also very important. You want to do a little bit of homework to see what you have inside your can light and match the new LED bulb to exactly what you've got so that your outcome will be basically the same as what you already have in terms of lamp color, temperature, and distribution of the light outside of the light fixture. We received about 100 of these light bulbs from GPG through the GPG program, and we liked them so much that we went ahead and bought something like 600 of them, and as a part of it, we tested a lot of different technologies out of this particular manufacturer. We ended up testing a short bulb and a long bulb in similar type can lights, and we're kind of surprised at how different the light spread was out of each one of them. And that's why I emphasize that you want to do a little bit of homework to make sure that what you're getting out of this technology matches what you already have in your can lights. We also bought some HID fixtures. Here in Auburn, we have a large site. We have a lot of exterior light fixtures with quartz lamps that we were able to actually modify with LEDs very economically using the same technology out of the same manufacturer. The results were very, very successful. We were able to replace all of our quartz lamps with LED very efficiently, and basically we bought our light bulbs with our BA63 funds. We handed it over to our O&M contractor, and the O&M contractor installed them with their O&M hours. So it was a very economical installation, and the energy savings definitely talked for itself. Next slide, please. There are a few loopholes to look out for. Number one is maintenance. The existing ballast will remain inside the can, inside the light fixture. So if the ballast fails, you're going to have to look for the same ballast to make the light fixture operational again. In all the installations that we had, I would say about 600 Lunera lamps, we only had one failure, which turned out to be the ballast. We were able to replace the ballast and get the light fixture operational again. The other loophole to look out for is utility incentives. Our utility company in this area does not incentivize this type of a retrofit, simply because it's very easy to take out the Lunera lamp and put in the new lamp or the compact fluorescent lamp and basically wipe out your energy savings. So for that purpose alone, our utilities don't incentivize this kind of a retrofit. As a result of this test that we did in the GPG program, we actually identified other retrofit options at our border stations. We were able to modify a lot of our outdoor lighting with LED, and in majority of those installations we were able to bypass the ballast and basically install an LED bulb that basically did the same thing but was receiving high voltage, 277 voltage for directly to the LED bulb. I believe this is it for me. I'm going to pass it on to Frank in Region 7 for his presentation.
Good morning, everybody from Fort Worth. Next slide, please. Yeah, I pretty much had the same experience Marty did. Our only difference was ours was a horizontal application versus vertical. We had 2 lamps versus 1. So I would just want to add a few things, and I think Eric may have already touched on this. I think it's always a good practice to interview the O&M or the facility maintenance crew to see what kind of existing experience they were already having with failures. You don't want to do this plug-and-play application where you have high ballast failures. you should consider doing the retrofit, as Eric alluded to earlier. And good rule of thumb is, if they tell you it's been like 25% or higher, I think, you don't want to do this particular solution. And also, while we were doing the project, we found that it was always a good practice to allow the ballast to cool down 10 or 15 minutes. We found when we didn't do that, we had some latency issues with the startup of the LEDs themselves. And I think a lot of that has to do is because these ballasts are running, 15 hours a day or so. So typically they were done after hours. So it was always good practice to let them cool down. Next slide, please. We did have one. Well, we had several lamps that had failed due to a manufacturer defect. However, Lunera was the one who pointed that out to us. We had one or two failures and didn't think much of it, but they actually brought it to our attention, and they were very quick to send us another batch of lamps. And that same batch is now in place, and it's probably been 2 years since we had to do that relamp and had no issues. And matter of fact, unlike Marty, we've had no failures in our ballast since doing this retrofit. We do have a project that's upcoming in the same building, the Cabell building in downtown Dallas, where we will be doing the remainder of the can lights in the building, which amounts to about 600 fixtures. Next slide, please. And with that, I wanted to mention our incentive package that we get from our local utility. And here's a map showing the Encore sphere of influence. And we were getting some ballpark figures from them just for the purposes of this meeting today. So we're going to replace 1,200 26-watt CFL to 13-watt LEDs. And so we can anticipate ballpark about a $4,200 incentive. Next slide. That's it for me. I'll turn it back over to you.
Thank you, Frank. And thank you, everyone, for your presentation. We are ready for the question and answer segment. And we want to thank all of those that have been entering questions in the meeting space window. If you have more, please go ahead and do that. While you've been providing some of your questions and concerns, we've been here in the background finding answers. So I'm going to go down the list of some of the questions that have come up, and we'll facilitate a discussion on those if needed. If anyone has anything to comment on any of these questions, please don't hesitate to add in. Andrea, are you releasing the mute, or are we going to do it a little bit differently?
No, you're going to, what we'll do is you want to ask the questions, and then the presenters can answer them. And I know we also have someone from Lunera, James. You've been answering a lot of the questions. If you want to unmute your line and answer some of these questions as well, that would be great.
Okay. Well, we'll start with the first question here on the list. The question is the current ballast in the fixture can needed or necessary? And are the weight of the lamps in compliance with the GSA P100? And James, if you are available, you're welcome to answer that.
Yes, and you can call me Jim just so I don't get confused, because my son's name is James as well. So,
okay.
So yes, the ballast for this specific lamp we're discussing today is required. These are plug and play with the existing ballast just for ease of use. That's the goal. In regards to the regulation question, I am not 100% sure about the GSA requirement, but I do know it actually exceeds by about 25x the requirement for UL for weight.
Right, and I believe that we looked at that when we did the demonstration for the P100 requirement, and we did not find any concerns there. So I would say that the answer is that they are in compliance with P100. Next question here. We're talking about the PL LED lamps, and how is the technology different than the PL LED lamps? James, are you able to answer that?
So I think generally the question, the way I read it was, there's a lot more on the market than there were in 2016. In 2016, I would say there's probably only 1 or 2, maybe 3 on the market with this product. Lunera actually invented this in 2013, and since then, the Chinese have fully engaged in this market, so there are other available on the market today.
Okay. There's a question that came up about compliance or being compatible with CFL ballast. I know that that question came out early, and we did have a lot of discussion about that throughout the presentation today. So, you know, like James said, it's a plug-and-play technology. They're ballast-driven. If they're incompatible, as Marty stated, that if there's magnetic ballasts that they are incompatible, then the recommendation is a retrofit kit or a new fixture. On to the next question. The color temperatures, the Kelvin temperatures of the light, where they match. We did our best in these demonstrations to match exactly the temperature color of the downlights. I believe the range that we were trying to stay within was 2700 to 4100. Most of those temperatures were in the 35 to 3700 range. Buy American compliance, the BAA requirements are part of the GPG requirements. We do require that these products do follow the BAA, and I believe that you can fill us in on your location and whether or not, or if you can confirm that for us.
So the way I understand this today, there is not any of these products actually made in the United States. So I believe they would fall under a waiver for this category today. There's not a single manufacturer that produces them in the United States. We do design and all the engineering in Silicon Valley in California. So I don't have a solid answer aside from that right now.
Okay, we'll move on. We'll look into that. I'm 100% certain that we wouldn't be able to have a demonstration with you unless you were BAA compliant. But thank you for that question. Next question here: can you place a cover over these cans? Clear frosted cover, some type of screen. What are the limitations on the cover?
So the lamps are rated for fully enclosed fixtures, whether that's over a can light or if they're in a wall sconce on a wall that's fully enclosed. They're rated fully for that heat load to be inside that enclosed fixture. The lamps themselves also have a frosted lens over them, so you have no glare issues with the LEDs. They're designed specifically with that nice look to them.
Thank you, James. A couple more questions. Do the bulbs come in bypass option? The answer from James here, I'll save you some breath. There are new universal mount bypass options available. Works with both horizontal and vertical. Next question about the flicker rate. Is that an issue? As we heard from our project managers, there wasn't an issue with flicker. It should not be an issue as long as the ballasts are deemed compatible. Next question from Michael. One issue that must be evaluated is that for LEDs, the heat output is at the base of the lamp, not the lamp itself. Can the retrofits an existing fixture? Yeah, go ahead.
Yeah, this is Eric. I can address that about the heat issue. It's very true that heat can be a potential problem with LEDs because the waste heat is not radiated like it is for an incandescent lamp or partially for a CFL. All that heat stays there at the base of the lamp. So if you have an enclosed fixture, that could potentially be a problem. But as Jim already noted, this particular product is rated for an enclosed fixture. They do tests with it in an enclosed fixture to make sure it'll withstand the heat. And that has to do with the electronic architecture and heat sinks, etc. So what you want to do is, when you go to buy a product, you want to make sure that it's rated for an enclosed fixture. They will typically say on the side of the box, not rated for enclosed fixtures, or that they are rated. So buyer beware, you need to pick the right product, make sure that it is rated for enclosed fixtures.
Thank you, Eric. Next question is the Design Lights Consortium, are they approved from that? And the answer from James is yes, with the caveat. James, if you can get into the detail of that, of the bypass the ballast option.
Yeah, so the DLC for 4-pin specifically, they actually don't approve any 2-pin lamps, which the 2 pins are what work on the magnetic ballasts. So those are available, but DLC does not cover 2 pins or magnetic ballasts. The 4 pins are approved on the DLC list as long as the lamps themselves are using an existing ballast. If you're bypassing the ballast, those lamps don't have any category within DLC.
Thank you, James. Next question, are these LEDs dimmable for power shedding application? James, I'll hand that over to you again.
Yeah, so the lamps themselves are dimmable on certain dimming ballasts. Again, it all goes back to that ballast compatibility. We have a pretty extensive list of those, and that's where I said just reach out to us with your actual ballast that you guys have in place, and we should be able to address that directly.
Great, thank you. Another question about the 277 volts. A question about safety concerns on bypassing ballasts that have 277 volt directly available for possible 277 volt direct contact.
Yeah, so the one thing I'll note here is that the ballasts themselves don't limit the actual voltage under 277. Now they do limit the amperage, but you can still have up to 600 volts coming out of that ballast into that socket. So in general, just touching sockets would be a safety hazard in general. UL has confirmed and reconfirmed many times that the bypass the ballast options are safe. It's just, again, following the actual instructions to UL code.
Thank you, James. Next question about warranties. What are the warranties that come with this? The answer from James is a full 5-year warranty on the Lunera lamps, and with P8 LEDs, they come with a 7-year warranty. What is the typical lifespan for the LEDs? James answers 50,000 hours lifespan, as you probably see in most LEDs. A comment here about the P100. It does not allow for retrofits where 277 is directly available. And then the response from Jeff, 6.3.2.2 of the P100 calls out a list of requirements for LED lamp retrofits. These are there to assist in ensuring that the lamps will actually perform as needed. Not much of it, not a clear answer on that, and that's something that we can look into and follow up on regarding some of the questions on the P100. Let's see here, and I think that's about it. I don't have an answer to the average cost per lamp. Is that something that we had in the report, Eric?
Yes, there is something in there, and I was just looking for labor rates, which came from RS Mean. So the information is in the full report. A lot more detail in there.
Yeah,
and
a lot of detail regarding the cost. Go ahead.
Sorry, I was going to say I can add the on the average cost. It's come down pretty dramatically since the 2016 report. So that's something else you can reach out to us or to local suppliers for.
Yes, for price, for understanding cost, I believe that contacting Lunera directly is the best avenue, since this report is over 2 years old, and those numbers will definitely change. I don't have any other questions here, and hand it back over to you, Andrea.
Great, thank you, Michael. I think at the time of the report, the cost of the lamps was $22 per unit. So that was what the payback was based on that cost. And the savings that were calculated at the average rate, so this is per lamp, was $6.37 a year. So that makes it an easy way to calculate the costs and savings. So thanks for all those questions. As we mentioned at the conclusion of today's webinar, you'll all receive a short 5-question survey, and completing that survey you can request continuing education credits. If you don't receive the survey, please reach out to Michael Hobson. And thank you all for being here. This is truly one of the simplest technologies we've evaluated to date. So I think it's fitting that it's a shorter, we're completing this in a record time. The next webinars that are coming up are more complex technologies, and we hope you can all attend. Thanks again for being here.
This is Kevin, and
yep.
Kevin Powell, I guess it's the last word sort of thing. First of all, I want to thank everybody for attending, and it's always great to be able to wrap one of these quickly. As Andrea just said, this is really literally one of the simplest technologies that we've tested, and our program looks at things that are both extraordinarily complicated and sometimes extremely high dollar value, and sometimes relatively simple and relatively low dollar value. What we would say about something like this particular one, when we think about broad deployment, is that this is something that should be essentially this product or something similar to it should be a no-brainer, really. It's something that should just be the way we do business. Because, again, I think there was a question initially, how can there possibly be $600,000 of annual savings from something as simple as just swapping out these lamps? And the answer is because when you look across the portfolio, even if this is essentially relatively a niche thing, that is to say downlights are not how we generally light office space, there's a lot of downlights. And this is something that, again, I think is just easy, quick payback, lets us really achieve a great deal of savings. So do want to thank everybody, though, who has participated in this call, and hopefully that's the takeaway that you have from it.
Thanks, Kevin.